services. Now, we'll before beginning with the rest assured, we'll talk about the Java basics. In the coming up classes, like I told you, we'll discuss about some Java concepts that are going to be used within the rest assured. Okay, so you must be knowing about the basic Java, how a class is built, what are constructor, and like all the stuff, right? Or you
Yeah.
Yeah. So I will talk about it, but I'll be more focused over the rest assured part, right?
Sorry, I missed
Okay.
the part. Come again.
Okay. Okay. So I was saying, I'm going to talk about the basic Java, but it will be much more focused over the rest assured side. You
Yeah,
got
that's
me
better.
with this?
Yeah.
Yeah. Okay. So the first thing that I'll talk about the concept is the concept of static and the non-static. Okay, so we do have some static variables in the class. We do have non-static variables. Same goes for the functions. We have static functions, non-static functions. Okay, so in order to understand it, I'll talk about the technical jargons later on, but first I'll present you an example. From that example, we'll try to understand. Uh, in this particular example, I'll take everything, what is a variable, what is a function, how object are created, why objects are created in a Java class. So I'll create a new project here, first of all. So the projects that I'm right now building are all the Java-based project, but within the rest assured, we are going to follow the Maven. So, okay, here we go. So right here, I'm creating a class here. Let's say the name of that class is Planet. In this particular class, let's say Planet has some properties, like it has some name. It will have, the planet will have a name, and let's say it has another property called shape, what kind of shape that planet holds. Okay, so initially I will declare some variables, and the variables needs a data type. Anything that you write in front of the name of that variable is its data type. So basically string is a data type, it's a non-primitive data type, but we're not going to that side, but it's just a data type. The data that we are putting on, it's a type, it's a string type of data. So the name of the variable is name, and I'm just declaring it right now. I'm not giving it any value. If I'll put a name here, let's say earth, that means right here I declared as well as defined this variable called name. Okay, but right now I'm not giving it any value, so I'm not defining it. I just declared a variable called name that has a data type string. Okay, so I'll create another variable, let's say shape. Okay, which also has a data type called string. Right. Now, in every Java class, there is a method called main. That is the method that executes first, right? On the priority order, this is the thing that execute first, except the static initializer block. I will talk about it, when we'll need it. Right now we don't not need it, but we'll assume that main is the method that called out first when the compilation begins. Okay, so here I created the main method. Now, in order to access these variables of this class within main, I need a reference through which I can call these variables. Okay, this reference is nothing that is known as your object, your class object. Okay, we give it that object, will give it a name, that is our reference. So for the planet class, if I create an object here, I'll say planet. First of all, I'll write the name of the class. Then I'll write the reference name. So let's say I'll name the object reference as obj. Okay, could be anything. Or let's say I'll name it as P1. Then with the new word, I will initialize it. And again, the name of the class for which you are creating the object, it's constructor, and end it. Okay, so now what I just did it at some memory location, these two variable are stored, and p word is pointing towards it. at that memory location. So basically using this P1, I can call out these variables. Okay, if we'll, more precisely if I'll talk about it. So I created, there is a memory location, right? Where are these two variables stored called name and shape. And I created an object reference called P1 that is actually pointing towards this memory location. Okay, now let's say I create another object for this class. Suppose in this planet class, I'm storing information about different planets. So I'll create a different object obviously. So what if I create another object here, planet, and I'll say P2, okay, equals to new planet. So I created another object, right? Now I want to now want to define uh, these variables, right? So first of all, I want to define it for the planet which has the reference P1. So I'll write P1 dot name equals to, let's say, Earth, right? And I also want to, define shape of this planet. So again, I'll write P1 dot shape. Let's say that is equals to circle. Okay, same thing I can do for the another planet class object, that is P2, again P2 dot name, let's say equals to Jupiter, right? And again I'll write P2 dot shape equals to circle. Okay, so now what I just did, for the same class planet, I created two different objects and a different value will be assigned to the different objects properties, this name and shape variable. So if I'll go back to that illustration, what I just did is I created this P1 object that is pointing toward this name and shape. Okay, and that will be equals to Earth and circle. Now I'll create it. There is at some other memory location, there is another object reference called P2 that is pointing towards this location, which has again these variables but with some different values. This time it's Jupiter, and another variable has value called circle, right? Now now let's say I'll create another object. Just I'm trying to explain you something here from this example. So if I create another object here, let's say planet P3, right? And again, I'll pass some properties to it. Let's say this time it's Pluto. Okay. Now you see one thing. Okay, I'll print down these properties too. So even if I want to, print out the values in the console, I have to use the object reference with it. So I'll say name of the planet is this. I'll use the concatenation here and we'll pass the name of the variable with its object reference. Okay, and let's say shape of planet is, okay, I'm just trying to print out a nice output on the console. So here I'll pass the shape variable, so it's a p1 dot shape. Same thing I'll do for the other object reference variables too. So 3 of 1 are there, only this will change. So p2 dot name and p3 dot name, whereas for the shape p2 dot shape and p3 dot shape. Okay, so now if I'll run this in the output, I'll see all these values. Okay, here we go. So it's saying the name of the planet is Earth and the shape of planet is, okay, I didn't, and it's p3 actually. Okay, so now if I'll run this, okay, so the name of the planet is Earth, shape of the planet is circle, name of the planet is Jupiter. Okay, right. So a single class, this is the definition of a class, that a class holds object of same types, right? So all these has same properties, but different values, right? So multiple objects created, values passed. Now the problem arises here is if you look at this code, this shape variable has same value throughout the object, throughout the whole class, right? If I go back to the illustration, you will see that I also have created another values have been passed to these variables. So it's Pluto and shape was again was equals to circle, right? And P3 object reference is pointing towards this memory location, right? For the name property is it's understandable that they have different object references because this property has a different value. It has different value. The name has different value here. It has different value here. But this shape variable has, the same value, right? Again and again, I'm repeating something, that I know that the all planets are circular. Then again, I'm defining it, which is, in some way it's incorrect, it's not the right way of writing code. So instead of, at this memory location, why don't we put the circle at some common memory location? Let's say this is a memory location, except, this shape variable, let's say all other properties, right, which are common among all the objects, right? All the properties that are not dependent on their object, because they're same for all the object references that are going to be created for this class or any class. Why don't they be stored at some location that is accessible by all? So it's the common property shape, and I'll store it at some other memory location, or let's say at the class location, the class has access to it. Okay, and all of these objects automatically that are part of that class has access to this location, right? That will be more right. The properties that are different, that should be the only one that called out by the object reference, right? And that are similar, that should be called by the class itself. Okay, so how I can do this? the at this point the concept of the static and the non-static comes. The variable that I have created earlier was the non-static variables. These all were the non-static, right? That's why every time if I want to pass a value to a variable, I have to call it by its object reference. But if I make this variable static, let's say I'll make this variable shape static, then I do not need the object reference to call it. Okay, its value, it's going to remain same throughout the class. I don't need any object reference. Right after putting the static in front of the shape variable, I'm getting a warning here. It's saying the static field planet.shape should be accessed in a static way. By a static way, it means that you don't need an object reference to call it. Okay, so if I remove this object reference, right, even I don't have to call it again and again. I set its value. It's going to remain same. Okay, but for a non-static variable, if I directly try to call it, I'll get an error. You cannot make a static reference to a non-static field. Okay, so right here, my name variable, which is not a common property among all object, is non-static. Whereas the shape variable, which is common property, right? So I make it a class variable. I make it a static variable. Okay, so I just have to call it once, and again, from the class, it will be called. it doesn't require any object reference now. It has the same value, so I'm not calling it, again and again multiple time after the each class is getting called. I just assign its value once and it's ready here. So if I run it now, the output will remain same, but we change the backend code, right? The output is same. Earlier we were getting the same output, but this is how, this is why we created this variable shape static. Okay. I hope you got the concept of this creating a static variable. Why we actually create a variable? Why we actually make a variable static? Okay,
Yes.
Muthu, you have any doubt?
No, yeah, I'm good.
You got the concept?
Yes.
Okay. So Matthew has just joined the class. So Matthew, in the last classes we have talked about the introduction to the API, what were the web services, basics of rest assured what we need. Okay, with this class we started with the Java, and in the coming up lectures we are going to discuss about the Java, and after that we'll start with the actual rest assured course. Okay, so now we just discussed about a static variable. There is just one more thing that I want to tell you about the object referencing. Uh, the part that we have missed. That even that the P1 the illustration that I have shown, that P1 was pointing towards this memory location, P2 was pointing towards this memory location. But let's just think about it. Let's do a quick revision of this concept. So right here, if I write something like this here, if I say P1 is equals to P3. Okay. So do you have any idea what will happen? You can tell me. If I'll write that the object reference P1 is equals to P3. Okay, so there are two things can happen. All the properties of P3 will get equal to P1, or all the properties of P1 will get equal to P3. What do you think what will happen?
Yeah,
Or
actually,
it doesn't make any change. You saying something, Matu?
no, actually, P1 equal to P3 is the property will be same, like both. I mean,
So you're
when you
saying
try
that
to,
the properties of P3 will be equals to P1, right? So that
yeah,
means uh, okay. So also Matthew is also saying that the properties of P3 will be equals to P1. So that means that P1 this particular line here will print out Pluto instead of Earth. This is what you're saying, right? So let's check it out. So if I run this now, it's saying yeah that now this P1 is actually pointing towards the P3. So what just happened is when we say that the P1 is equals to P3, it stops pointing towards this memory location, and instead of this, it starts pointing towards the memory location where P3 is pointing. Okay, it's a very common thing that you'll see. This is just a small concept that I want to tell you about. Okay, now the same way we have created this static variable, same way we also create static functions. Okay, there are some functions that are static. Even in the REST assured libraries or even in the pre-existing Java libraries, there are some functions that are static. Okay, there are some predefined static functions, and there are also functions that we create, we ourselves, by our choice will make it static. Okay, so now I'll talk about it. Okay, I'll just take a quick 1 minute break. Just okay, yeah, just begin. So yeah, we were talking about now the static function. So let's say within the same class, okay, right here. First, I'll create a normal function. Just forget the static and the non-static. Also, just think about it. Right now, if I want to print the name of this name variable or even this shape variable, again and again, I'm calling this, system.out.println, right? So I'm again, yeah, repeating the code. So something is wrong about it. So we can make it better. So We can make it better by creating a function. We'll create a simple function that will print the values, right? Instead of again and again writing the same code, we can create a function here. So I'll create a function here. Let's say void print name. Okay, so this is the function. Like the variable, a function also has a, not the data type, but it's called as the return type. Like this variable was of string type. This function can all be of string type. By that means, when I write string print name, that means that this function will return a string value. That's why it's not known as a data type, it's a return type. Okay, defines the return type of the function. So now I'm getting an error because this method must return a result of a string type. So right here, if I write return, if I return a string, so return ABC, some string. Okay, so then the error will be removed. Okay, but in my case, I don't have a defined return type, so that's why I'm using void. When you're using void, you're not bounded to return something. Okay, now there is no error, so that's why. So now this function will simply print a, okay, there are types of function. There are some function which are, there are three types of function, I'll tell you. It's a non-parameterized function, basically the function that doesn't have a argument or a parameter in between. No parameterized function. There are some parameterized function that requires a parameter, and there are some static functions as well as the non-static ones. Okay, so static, non-static, I'll come to the concept. Let's talk about the parameterized and non-parameterized. So the function, which requires some parameter for its execution. If it requires something to be passed in this parameters, that's a parameterized function. Right here, I created a non-parameterized function, but I need to pass a parameter, right? What I need to pass, I need to pass the name as the parameter. So I'm just creating a variable here. Let's say string a. So whenever this function will be called, a string type of variable should be passed. A string object should be passed. Okay. And what this will do, it will simply print it. It will say the same thing that I was calling here. Okay. So I'll just copy it. We don't need this now. We'll directly call this the function. Okay. So this will print p1 dot name, not now. It will be the string a. Okay, I'll say string n and let's say string s for the shape. Okay, so this will print n and this will print s. Okay, so now again, I'm not writing multiple lines, just to print the values. Now with the object reference, I can directly call the function. So right now, here is the function. I can simply call it. So I'll say for the p1, if I'm calling it, so I'll say p1 dot print name. I have to pass two values, two string values. First one is the name that is stored inside p1 dot name, right? And another one is the shape. So I can directly call it because it's a static variable. Same thing I can do for the p2. Same thing I can do for the p3 point. p3 object reference. Okay, so it's a p2, p3, right? So again, the same thing will get printed. I'll run this. Output is still going to remain same, right? But just we did it in the right way. We are not repeating the code. We created the function to print the values instead of multiple times writing the same line. Now, now the thing here is that the function that I have created here is my static function. Why it is a static? Because first of all, whenever we'll create non-static, we'll write a keyword, but that's not the reason. Uh, it requires the object for its calling. Whenever I want to call this print name function, I have to I need the object reference. Okay. And even, if I call it by the same object, because all this object has access to it, it's not no problem with this too. I'll run this, still the output will remain same, right? So again, this is a common functionality that for all the object references, I want to print its detail in the console, right? It's not a different function for, the different object references, right? So why don't I again make it static? Why it's non-static? So if I'll write here static, okay, so okay, first of all, it's okay, now it should be fine. So now I do not need any object reference here. Okay, I can directly call it because it's a static function. You see here? So again, I will call it, the output will remain same, right? So this is why and how we create the static function. It's a static function that is parameterized, needs some parameters. And even in the Java libraries, like there's a math library, you see the functions like the add or the equals, all those functions are static. Why they are static? Usually a function is we make the function static because this is a kind of functionality that is then that in itself it's repeatable. It's again and again going to be used. Print name is can be used again in this class somewhere. Okay. It's a common functionality. For a unique functionality that is going to remain different for the different object references, right? That will be make as the non-static one. So that's why we create a function or a variable static. So this is the concept of static that is going to be used throughout again and again. Right here, with this any variable or the function, I didn't used any keyword like the public and the private, because when this comes into the picture, there's a slight change in the definition of the nature of static and a non-static function in the variable. But we'll see in the coming up lectures when we'll actually talk about this access modifiers. There are 4 access modifier. So it's not limited to the public. It's there are public, private, default. There are 4 types of this access modifier present, right? So in the coming up lectures, we'll see that. Okay, so and one last thing that we'll cover in this section is we talked about the variable, we talked about the functions, we got to know about the concept of static and the non-static, very important one. Now, there is in this class, we do have constructors also. Okay, so what the constructors are useful for, the main purpose of a constructor is, uh, before that, the concept of static, non-static, variable and function is clear to you. Then I'll talk about the constructor. If you have any doubt about it, if you want me to repeat anything. Okay, Matthew is clear with it. Muthu, you're clear with it?
Yeah, I'm good.
Okay, okay. So yeah, so I was talking about the constructors. So the constructors are used for the initialization purpose. Like right here, I declared this variable. I was initializing it separately. Right, I was declaring the object here. After declaring the object using the reference, I was defining it. But what I say that there is a better way of doing it. Okay, instead of first declaring the variable, then creating the object reference and then using the object reference, passing it a value. There is a better way of doing it, defining a variable, and that is through the constructor. So within the same class, okay, I'll just remove this function for a while to make some, okay. So now if I'll say that I can create a constructor, firstly, yeah, Matthew just asked that we create constructor for the initialization of instance variables. Yeah, right. This is why we used. Okay, so how do we create the constructor? By the name of the class. If the name of the class, just write the name of the class again. And the constructors are of 2 types. There are parameterized constructor, there are non-parameterized constructor. The constructor that I am creating right here are the parameterized ones. Okay, so I will say string name and string shape. Okay, now I started getting an error here. I'll come back to it. Why we getting an error here? So I'm using this constructor for the initialization of these variables here. Okay, my global variable, my instance variable. So right here, I'll simply write this dot name equals to name. Okay, so if I hover over it, you will see that this name is equals to this parameterized name, whereas this name is equals to my instance variable. Why I use this keyword? Because both of these variables name are same. If I don't use the this one, okay, it will just saying, this name is equals to name, which doesn't make any sense. My requirement here was that my instance variable name should be equals to this parameterized variable name here. Okay, and both the names are same, that's why I have to use this keyword. Okay, if I use a different keyword here instead of this name, I don't have to use this keyword. Then I can say n equals to, let's say, name. Okay, again it's the same thing, that this parameterized name is equals to our instance variable name. But why I'm choosing name here? Because when you are working with the actual project, you can't just give any name to the variable. When I know that I created this parameters for the initialization of this, so the name should be same. Right, and like at the end you will understand, but the other person is not going to understand. So there should be a symmetry. That's why this keyword is used. The names was similar, so I'd say this dot name equals to name. Same thing I can do for the another variable shape. I'll say this dot shape equals to shape. Right, now if I go back to my main function, when I was creating this objects, Uh, you see, now I'm getting an error. First, let's read the error, what it's saying to us after creating. So it's saying constructor planet is undefined. You know why it's saying that? Because whenever we create the object, we are not actually creating the object of the class. We are calling out a constructor, and now our constructor is parameterized. So do our object should be. Right, my constructor has this parameters, so those parameters should be passed while creating the object. So instead, giving it a name or a shape right here, I can directly give it here. Okay, and by actually we don't have to pass the shape here, because shape is a static variable, right? Can be called out here. Uh, we are creating different object for the name property, right? So while calling it, I can pass the name. So I don't have to do it now this separately. Right, p1.name, I don't have to do it, I can directly pass it. So let's say the first object will be initialized, will be created with the name equals to earth. Second will be created, say, Jupiter. Okay, the third one will be Pluto. Okay, now when the object creation happened at the same time, initialization of name variable got done. Right, I don't have to do it separately. So earlier you see that how big this clause was, but it was a very small code, right? If you do it the right way. While creating the objects, I actually set the values. I actually defined my variables too. Again, I can, okay, I deleted that function, but I'm not creating function, but I'm directly calling it right here. So again, you can directly call it. Okay, so p1.name will again will remain same to that. The same goes for the p2 and the p3. So this will be the p2.name, p3.name. I will run this. You will see the same values are getting printed. Right? You don't have to separately call it. While creating the object, I'll pass the values. Okay. So this is why constructor are used. Main work is for the initialization. Function are used to define a common functionality. We make a functionality static when it's common among all the objects, right? It serves the same purpose for all the object references. If it performs different activity for it, it is used as a non-static one. Right? There are parameterized constructor, there are parameterized methods. So this is about the basic of a Java class. how objects are created, what are variables, different functions, methods, static, non-static. Okay, I hope it's clear to you. Again, at last, I'm done with my part today. So now you can ask me if you have any doubt about it from the last session or anything that you want to ask before we'll end this session.
Okay.
Yeah, Matu.
Actually, yesterday when you shared, right, the Postman, even I
Hmm.
downloaded and I tried it. Somehow for
Okay.
me it didn't work. Can I share my
Uh,
screen?
what went wrong?
Uh, we downloaded. I downloaded the jar, the student, the student application,
Okay.
um, the student application at the
Mhm.
rad jar. When I tried it,
Mhm.
let me
Mhm.
show you the screen.
Okay. Yeah.
Are you able to see that?
Yeah, I
Okay.
can see your screen.
Okay.
So you have installed the Postman, right?
Yeah, I installed the Postman and I tried to have some. That's it. And
Yeah. Postman installation failed.
yeah, okay, some
Uh,
issues there.
this.
Let.
So you're not able to install the Postman. That's the issue, right?
No, actually, yesterday I installed it.
Mm-hmm.
And installed. Let me
Actually, I
put it.
think you're just opening the setup file again. You have to open the installed application. You can search for it. Click. I believe it's installed already.
So here, yeah, it's in desktop. I'm trying to open it.
Mm-hmm.
Okay, let me work. My I
Okay, so let it open. So when you after opening the Postman, you have to start the student application, right?
yeah.
Okay, so when the issue, what was the issue?
Actually, the get to a get came actually. Whenever I put a get right, it
Yeah.
worked. But when I
Uh-huh.
try to update anything, right, it didn't work actually. It says some error. That's why I'm trying
Okay, so
to.
did post worked? The post HTTP method.
Yeah, the post didn't work. Actually, post or put anything didn't work.
Okay, okay. So can you show me your JSON? When you were, doing the post request, you made a JSON, right?
Yeah, that's why I'm just trying to open it. Everything I saved it in the folder.
Okay, 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 okay. No
Postman
problem.
itself.
Let it open. Let it open.
Some issue there. I don't know. Somehow it's not opening. Can I try again installing?